All right, here's our video today. Trigonometry, Algebra 2. It's Algebra 2 / Trigonometry on the regions. This is the unit circle part 1. So we'll go over the unit circle. Just a simple video for this one, for the part 1. And by the way, that's not a circle right over there. That's an ellipse. So let's get a circle. So here we have a circle. I'll get my pen ready. Let's use green. So obviously that's a circle. And if I make a line, we'll put a line straight down. Try to make it as straight as we can there. It's a little blurry. Let's do it over. Clear that out. And we'll do it again. Try it again. And so now we have our x and y plane. We know that's the x, and we know that's the y. So a unit circle has the word unit in it. So it means 1, right? So this could be 1 foot. It could be 1 mile. It could be 1 yard. Could be 1 centimeter, right? It could be 1 light year. It doesn't matter. It's just one of something, right? That's the measurement. And so that's why we say unit, and you know that already. So the unit circle means that the radius of the circle, the radius is 1 unit, whatever that unit may be. So all radii on the circle, all the radii, if I make any kind of radii on this circle, it'll all be 1. All right, so that's 1, that's 1, that's 1, right? Etc. and etc. Right? So we know what the unit circle is. Let me clear that out. Let's do this again. I'll change the color. Just change it up a little bit. Use that magenta-like color. And making our x and y graph. Remember, that's x and that's y. So from the center here all the way to the end, make that a little thicker, we know that this will be 1 unit. And therefore, that this point, we'll change it, put a little green. That green point over there will be 1, 0. It's 1 for the x and 0 for the y. So that's 1, 0. And on top of this will be, we'll put this point over here, that'll be 0, 1. Because it's at 0 on the x and 1 for the y. Because remember, it's all 1 unit. And remember, when we're talking about angles on the unit circle, they do go counterclockwise. There's a little arrow counterclockwise. All right. And so what do you think this point would be? Right? On the x, it's -1, and the y is 0. And this point, you got it, right? It's 0 for the x and -1 for the y. So we know the points. All right, we'll clear that out again. Clear it out another time. Let's make another one. This time we'll make it a little more purple. All right, we'll make a straight line there. Attempting to make a straight line there. We know that it's x. We know that is y. And there's the center of the circle. Now, when we're dealing with unit circles, we need to know radians. Now, when you first learn about geometry, talk about degrees. So the first concept we should do is knowing how to go convert degrees to radians. That's the first concept we have to know. Now, if we look on with degrees, right, we can say, well, this is 0 degrees, 0. But it's also, if you make a complete circle, we know it's 360 degrees. And half a circle, we know, is 180 degrees. We know this already. And then when we have half of our half, a quarter of our circle, our right angle, it's 90 degrees. And we have over here 270 degrees, and we can just keep adding degrees on that. Okay, so let's see, how can we, we'll start with 30 degrees. Let's say that's 30 degrees right there. How can we convert 30 degrees to radians? That's the first concept. And here's the formula. I'll give you the formula. The formula is you're going to take whatever the degree is, and you're going to times it by pi over 180. Pi over 180. So let's look at it one. We'll change it to green here. We have 30 degrees times pi over 180. So that's going to give us, if we cross out the 30, if we simplify here, that's going to give us pi over 6. So 30 degrees is pi over 6 radians. Just remember the formula right over here. Now, if you remember that 30 degrees is pi over 6, there's another way you can do it also. You can look at, well, what about, put that purple back in there. What about 60 degrees? Well, 60 degrees would be 2 pi radian. 2 pi over 6 radian. And 90 degrees would be 3 pi over 6. So every 30, I'm just adding a number. And then if we had 120, 30 more after that, what do you think 120 would be if we follow this pattern? Pi over 6, 2 pi over 6, 3 pi over 6, every 30 degrees. We're just adding a number. Well, 120 degrees would be 4 pi over 6. What about 150? What about 150 degrees? 30 more degrees after that. What would that be? 5 pi over 6. And 30 degrees more would be 180. So what should 180 be? 6 pi over 6. Now remember, you should simplify. So if you simplify 6 pi over 6, it just becomes pi. 5 6 over pi will just be 5 pi over 6. Can't simplify that. 4 pi over 6 would be, you can simplify that to 2/3 pi. 3 pi over 6 could be simplified to what? What do you think? 1/2 pi, right? And 2 pi over 6 and so on. So again, let's just look at the formula. We said that 180 degrees is pi radian. So we say 180 degrees. Remember the formula over here. There's the formula. 180 degrees times pi over 180. They cross out, and you just get pi. Pi radians. So if you can follow this formula, you can convert degrees to radians. Rewind the tape if you need to do that. What if you wanted to convert radians to degrees? What do you think you should do with that? Oh, let me make another circle here with the x and y graph. There's the x, there's the y. All right, so remember the formula for degree to radian, and then we'll do it again, radian to degree. So degree to radian, you take the degree, and you times it by pi over 180. For radian, you take the radian and times it by 180 over pi. Just flip it. So just look at those two and just flip it. So again, if we had 30 degrees, times it by pi over 180. Right here you can simplify. 30 goes into 186 times. So it'll be pi over 6. 30 degrees is pi over 6 radians. Now, if you had 30 degrees, the radians is pi over 6, and you times it by 180 over pi. Flip that, those cancel. 6 goes into 180 30 times, 30 degrees. So try this. So we had 30 degrees. Remember we said 30 degrees was pi over 6. And 60 degrees was 2 pi over 6. So convert 2 pi over 6 times 180 over pi. And what do you get? Why don't you try that one? Now, obviously, you know you're going to get 60 degrees, but see if you get 60 degrees. And remember, you can simplify this, right? Instead of saying 2 over 6 pi, you can say, we'll just change the color. Cross that out, it'll be 1/3 pi. And then you can cancel the pi's out because right? Cancel the pi's out. So you have 180 over 3, which gives us 60 degrees. So again, this is the formula degree to radian. This is the formula radian to degree. Now the last thing, just for this video, because this is just part 1, we need to remember the trig ratios. Let's clear that out for a minute. So remember, we're going to start with 3 of the trig ratios. There are 6. But you should remember sine. And on the calculator, you'll see it as sin. It's sine. And there's cosine, which on the calculator, you have that button. And then there's tangent, which on the calculator, you have that button. These are trig ratios. And there's more. There's 3 more. But for now, we'll just look at these 3 and just make sure that we remember how to use them. So if we have a right angle here, a 90-degree angle, we know that this line, the longest line of the right angle, is the hypotenuse. And usually it's denoted with a C. And then the other legs are A and B, and it doesn't really matter which one is A and just which one is B, but that's the convention of it. So if I had a degree here, let's say we had a degree right here, when we don't know what it is, so we just say theta. And it didn't come out right, but I'll blow it up. That's theta, or theta. Some people say theta, some people say theta. It's a Greek letter in the Greek alphabet. And it just means we don't know what the degree is. Some unknown degree right here. But if we look at what's opposite the degree, we put a line straight out. Opposite to this degree is A. That's opposite. And adjacent would be right next to it over here. So we have these words opposite. And then we have these words adjacent. Let's dot that J. And then we have the hypotenuse. So let's just make sure we understand that. I'll make one a little bigger. And we know it's a right angle. And here we have angle theta. Put theta in there. And opposite theta, let's say we put the number 3. So opposite of theta is the number 3. And the hypotenuse, let's say, is 5. This is the famous 3, 4, 5 Pythagorean triple. So again, opposite of the theta is 3. The hypotenuse is 5. So a trig ratio that is opposite of the angle over the hypotenuse is sine. So if we say sine theta, because we don't know what the degree is, we know the opposite is 3 and hypotenuse is 5. Now cosine theta, we have not opposite but adjacent over the hypotenuse. And if we look at sine theta here, a degree theta, adjacent to it is 4 and the hypotenuse is 5. So cosine is adjacent over hypotenuse, so that'll be 4 over 5. And then we have tangent. And I'll write tangent right in the circle. So tangent will be opposite over adjacent. So the opposite of this degree is 3, and the adjacent is 4. So it'll be 3 over 4. And that is the trig ratios. Let me do one more to make sure you understand that. Change the color. Use that color, why not? Let's say we have this right angle here. And let's say the degree is up here. And let's say we call it alpha. It doesn't matter what and we could call it degree alpha. We can call it theta, alpha. It doesn't matter. It just means some unknown degree. And let's just say that that's 7. We don't know why. It's just 7, and maybe this is 8. So if I wanted to say sine theta, sine alpha, we don't know what the hypotenuse is. But we know opposite of it is 7. And the hypotenuse, we don't know. We just put x. What would be cosine alpha? Cosine alpha. What's adjacent to alpha? The 8. And the hypotenuse? We don't know. And what would be tan alpha? Well, the opposite is 7, and adjacent is 8. So our next video, we're going to take this, more of this, and we'll look more at the unit circle and more on radians.